So
Yes.
so you said if we go to marketplace, we can just buy any application that is already pre-configured. Then we can any
Mm-hmm.
services. Then we'll be using.
Mm-hmm.
Okay, so those are like a AMI as well. Is that right? On
Yes.
marketplace.
Yes.
That's
Yes.
that being supported on AWS Web Services. Okay. Oh, okay.
Yes. So,
Ah, okay.
say you have right, you just created your virtual machine in AWS, okay, and maybe you just installed say Apache web server, right, in that instance, okay. Now say next time, right, whenever and you configured that Apache web server, right, as you like, right, based on your requirement, okay. Now, later on, right, you want to launch, right, similar instances, right? Say clone of that instance, okay? You want to just launch clone of that instance. So what you will be doing, you have one option, right? That okay, you use the previous AMI, right? And again, you launch your instance and then configure that Apache, right? You install that Apache web server in it, you configure it, right? Again, and you have another option, right, that okay, the instance that you already configured, right, with that Apache web server, right, now you can take image of that instance, right, and launch your next instance, right, from that new AMI, right, new image. So now this new image, right, that you will be using, it will already have, right, all the configurations and everything that you already, right, configured. Okay, so it
Oh,
will
okay.
be like right, pre-configured instance now you will be getting, right, with the application already installed. That is the Apache web server.
Okay, sounds good. That makes sense. Yeah. Okay.
Yep,
Right.
yep. So these are like right the blueprint right for your server, and you can use right marketplace AMIs, right, or create your own. So right, you can also use right the golden image, right, the one that we are actually creating, right. We are calling it a golden image for consistent deployments right across your fleet. Now, to create golden images, right, that is the custom AMIs. So we have AWS Image Builder, right, and that is a service, right. So we can use that right image builder to actually configure right these AMIs, right, what all right templates we need, what all operating system we need, right, what will be the runtime right installed in that. So everything we can select right from right, and we can create the image, and we call it golden image. Okay, so moving to instance types. So decoding the naming system, right? So in AWS, the naming convention, right, for instance types is like this. So you have M5 dot extra large. X large is extra large. So M here is the family. So this is standing, right? Stands for general purpose. Right? So this is the category, right? We will be exploring. So each letter, right, corresponds to a right specialty, right? So this is having right some specialty, right? So this M, right, is for general purpose. Now in general purpose, what we get, right? We get a standard, right? Say CPU, right, and RAM and the network performance, right? So everything will be right at standard level, right? That means uh, balanced level, right? So that is what this M family, right, is uh, mm, right having. So general purpose, okay. So you will be having right so for all right kind of broad right use cases, you can use right your M type or general purpose instance types. So then the second right letter that you have is 5. So it is the generation, right, it is or the version of right that. So higher number generally right offer better pricing right to performance right ratio. So definitely if you have 5, so it is the fifth generation, right. So definitely fifth generation will be right better right than the fourth one, right, the third one definitely, right. So it will give you right better performance, right, uh, right. And then after dot you have the size of that instance type. So size is actually right telling you right how much CPU you will be getting and how much right memory you will be getting, right. So extra large here determines right the CPU and the memory capacity. within that family, right? So whatever family you choose, right, the generation you get, and this will be the size of your, right, uh, your instance, right? That is the CPU and the memory, right? So if you have micro, you have small, you have large, right? You have extra large, you have, right, double extra large, right? So like that, you have, right, the sizes, right, that will vary, right? So then coming to general purpose, right? Generally we have TM, right? So these are for right, general. So these are instances, right, that provide a balance of compute, memory, and network resources. Right, so definitely when we say balance, that means, right, if you have broad array requirement where maybe you don't know, right, okay, whether I need more RAM or more CPU, right, you don't have any idea, and right, you can go for a general purpose, right, in that case, right? So general use cases for web servers, you can go for it, right? Small databases, right, for dev test environments, right, you can go for TM, the general purpose instance types, right? So M family consists, right, it gives you consistent performance, right, for your applications. Here, right, the CPU, right, usage and everything, right, will be consistent. And for T family, you get burstable performance, right, uses CPU credits. Now this is very, right, special, right, you can say a feature of this T family, right, burstable performance and CPU credits. Now every, right, T family instance type, right, will have a baseline performance, right? Say the base level performance, right, for the CPU, right, for T family is 20%, right, 20%. So that will be the baseline. So it will give you, right, 20%, right, as baseline performance. Now, when you are not actually utilizing, right, that say capacity of say 20%, maybe you are just using, right, you are utilizing 10% of right, the total of that baseline. Now, definitely the 10% that is left idle, right? So that will be actually credited as CPU credits, right? So later on, what you can do is whenever there will be higher demand for your right compute, so it can burst, right, beyond that baseline performance of 20%. So if you have credit of say 10, right, so definitely the baseline is 20%. Now, right, you will have, right, performance of 30% also, right, using your CPU credits. So unused, right, say performance or the baseline performance will be credited, right, will be right, given back to you, and your instance can actually burst, right, whenever it have, right, more requirement of compute. Right, so this is what burstable family types, right, will give you. So you can, right, use, right, more CPU, right, when you have a requirement, right, for that.
That makes sense.
Yes. So then we have here, we will be coming, right, to compute optimized, right, the C type. So these are ideal for compute, right, bound applications, right, that benefit from high performance processors. Now, definitely when we have a compute intensive workload, right, so where you need more CPU, so definitely we need to have instance types, right, that will, right, have better CPU, right, than say memory, right. So here the use cases like, right, you have batch processing, definitely, right, you need a lot of compute resource, right, for batch processing, for media transcoding, right. So HPC, high performance, right, compute, right. So you need, right, very good, right, performance, right, low latency. So for your web servers, for that you can use, right, compute optimized instance types. For that you have C family, right? So highest ratio, right, of virtual CPUs to memory. So definitely the CPU will be more for compute optimized, right, than memory, right? So this is where comes right your compute optimized when you have right a lot of requirements for your compute, right? And then we have memory optimized, right? RxZ, right? These families, right? Generally they have better memory, right? That is RAM. So really designed to deliver right fast performance for workloads, right? That process large data set right in memory. So here comes right the use cases right in memory databases. Now you need right you want right as you said right you have say a big right database right with 2 terabyte or right. Now definitely now right when you will be accessing that data when you will be fetching right the data from that database, right? There will be a lot of maybe delay, right? Or lag, right? Now to reduce that lag, what we can do is we can use right the cache, right? We can cache that, right? Frequently accessed data in the memory itself, right? So in-memory databases, right? You can use, and for that definitely you need huge memory, right? That will be actually caching right your frequently accessed data, right? So use right you can use it for right SAP HANA, right? And Redis definitely right to cache it, right? Analytics, so definitely real-time big data processing you can use it, right? So definitely when we talk about big data again, right? All those Redshift and everything, right? Your uh, data warehouses and everything will come into the picture, right? Where actually we are storing right data right in these uh, uh, Redshift in here, right? In AWS we have right the Redshift that is the data warehouse, right? So where we are actually pulling right or storing the data before right processing them, right? All those big data analytics and everything, right? We fetch right data from different locations, different sources, and then we run right all those ETL jobs, right? We clean and then we load right that data, and then right we run all those analytics on top of it, right? So here the RxZ, right? This family will give you right higher RAM, right, per CPU, per virtual CPU, right? So this will be idle, right, for use case, right, where you need right better performance, right, performing databases. And here comes again, right, the storage optimized, right? Now IDH, right, for workloads, right, that require high sequential read and write, right, access to very large data set, right, on local storage. Now, definitely, again, this will be also right important, right, for your databases, right? Because when you need low latency access to the data, right? So definitely, if the data is available in the in that local right storage, then definitely the access right will be faster, right? You can access that faster than if it is present in some network device. Right. So here the use case again NoSQL databases because right these are again very fast, right? So to access these data right faster, you can right go for storage optimized one, right? So generally, right, when we select the instance type, right, other than storage optimized, right, so we only select the CPU, right, your RAM and your network performance, right? But there is no option right for storage. But with storage optimized, actually, you will be getting storage also along with your instance type, right? So that is not available for any other instance types, right? So for data warehousing again, right, you can go for storage optimized log processing. So how high throughput, right, analysis. So definitely when you have a requirement for very high speed read and writes, so you can go for storage optimized. So definitely iFamily, right, gives you that, right? It gives you NVMe SSD, right, local storage. So that supports very high speed read and write, right? That means definitely the throughput will be right higher as compared to other instance types. So
So
then, yes,
sorry.
please.
So
Yeah.
storage optimized is going to be more expensive compared to memory optimized. Is that right?
Definitely.
Oh,
Again,
okay.
it depends, right? The configuration, right?
The
Based on the
generation or
configuration.
the
Yeah, and
okay.
you need
Got it.
to pay, right? You need to pay, say per use, right? So per
Oh,
second
okay.
charges will be applicable, right? For these instance types,
Oh, okay.
right?
Sure. Okay.
Yes.
Yeah.
So it will vary, right, based on the configuration. It is not like that. Okay, storage optimized will always cost you more than, right, your compute optimized or memory optimized. So it depends, right, on the configuration, because there are right multiple options available, right?
Oh, okay. Okay.
So
Sure.
how
That
much
makes sense.
storage you will be getting? Yeah, yeah.
Ah, okay.
So then you have accelerated computing. So the families you have PGF. Right, so here, right, when you have requirement for hardware acceleration, right, using say GPUs, right, so FPGAs, right, so these are right perform functions more efficiently, right, than your normal CPUs, right? So use cases again for machine learning, right? For 3D rendering, you can go for it, right? The graphics, video encoding, and gaming, you can go for it, right? Definitely wherever you have a requirement for GPUs. So P family, right? G and F, right? So NVIDIA, Tesla GPUs, right? So these are right example for accelerated computing. So where you have right a very high speed, low latency compute requirement. So for that, you need to go for accelerated computing, right? So it will give you the right fastest, right, say available compute performance, right? So quick summary. So family metrics. So again, right general purpose, empty. So it will give you balanced, right performance, idle workload, small to mid-size applications, compute optimized. It will give you right better compute right resource, and idle workload will be your scientific modeling, right data encoding. Memory optimized RX, it will right give you right better RAM capacity, right memory capacity. So idle workload will be for in-memory databases and cache, and you have storage optimized ID. So it will give you right better throughput. So the input output right operations right per second, that will be better. And idle workload will be distributed file systems, right, where you need right say faster reads and writes. Okay, so the pricing model. So let us get into right how you pay for EC2. So definitely the pricing mix, right? You have on demand, you have reserved and savings, and you have spot, right? So here these are just on top of it. Okay. So number one, right, you're on demand. Here you don't have to have any commitment, right? There is no commitment for use, right? So when generally we are creating, right, in our free tier in right accounts, we are actually creating on demand instances, right? On demand are one that you can create and get rid of them anytime you want. So you pay only for what you use,
Okay. Pay as
right?
you go. Okay. Mm.
Pay as you go. Very good, right? So that is right where you have pay as you go. Then you have reserved and savings, right? In reserved instances, right, you need to have a commitment that okay, you will be reserving right that say a instance type for 1 year or 3 year, right? There is again no 2 year option, only 1 year and 3 year. You need to have a commitment. So you say you are going for you will be reserving say T3 dot micro, right? That is the instance type, right? For 3 years. So definitely you need to right pay for those 3 years, right? And definitely here you will be getting huge savings. Okay, you will be getting up to 72 to 7 right 75% of saving as compared to on demand instance, right? Because here you are giving your commitment, right, that you will be right using them right for 1 or 3 years. So that will give you right a lot of savings, right? And then you have spot instance. Now spot instance will be again the cheapest option you will have here in AWS, up to 90% savings, right? Now again, these are up to right 90%. It is not always 90%, right? Because it depends on the available capacity, right? In any particular region, right? So successful AWS users, right, mix all these right models to achieve maximum return on investment, right? Now let us quickly compare this. Okay, so on demand, so pay by second, right, with no long-term commitments. So perfect for short-term, right, unpredictable workload. So this is again very important. So whenever you have unpredictable, right, that means you don't know how much, right, say compute resources you need, for how long you need it, right? So that is unpredictable. But if you know that, okay, I need to use, right, this capacity for 1 year, so better you go for, right, your reserved instance, right? Because if you know already, it is predictable that you need, right, at least 1 year of usage. So definitely it will save you up to 72%, right? So definitely that will be the best option, right? You will save a lot of money, right, with the reserved instance. Right. So, for short term, right, so that is right less than 1 year, and if it is unpredictable, you can go for on demand. And always, whenever you are new to, say, AWS, right, and you don't have, right, you don't know, right, how much, right, uh, you need, right, so you definitely you can go for on demand, where you just pay for what you use, right? Then you have spot instance. Now purchase right spare AWS capacity for up to 90% discount. Right, so you save up to 90% on spot instances. Right, now when you see right that spare AWS capacity. Now definitely, Wilson, when we saw that global infrastructure, right? We saw that there is a region, that is the geolocation, and those regions are divided into multiple availability zone, and inside those availability zone we had the data center, right? We had multiple, right, one or more data centers. Now definitely all these data centers are not being utilized 100% all the time, right? Definitely there must be, right, some spare resources, right, that is available in the data center, right, that is idle, not being used, not being utilized, right? So now what AWS do, right? So they say, okay, so here maybe we have, right, 20% of our resources, right, running, right, idle, right? They are still idle. So just right, definitely if they have idle resources, so definitely it is not making them any money, right? So definitely it will be a loss, right, for, because there is operational cost, right, and right, associated with those resources. So those spare resources or those idle resources, what AWS do is they give it up, right, for 90% of discount as spot instances, right? But here, the trick here is if they have requirement, right? So AWS can terminate these, right, with a 2-minute notice, right? These instances. So definitely, when you go for spot instances, you need to make sure that the application that you will be running on these instances must, right, be, say, flexible. They can tolerate such, right, say, disruptions, right? Because if, right, say, there is a demand, right, for, say, on demand instance, right, in that capacity, and right, there are a lot of spot instances running, right, in that, say, data center. So AWS will be sending, right, those users a notice, right? So right, that okay, you can just wind up, right, these spot instances, because we have a requirement, right, for on demand instance or any other instance, right, uh, right, type. So they will get a 2-minute notice where they need to take their application down, right? So they, this is the reclaiming of, right, their capacity actually, right? So it can be, right, it should be used, right, for application that can tolerate, right, such say flexibility, right, or interruptions. Okay, so commitment, right, and based, right, savings. So definitely if you're committing, so here you have reserved instances, right? So commit, right, to a specific instance type for 1 or 3 years, right? Up to 75 or 72% savings you get, right? So that is reserved instances. You need to select the instance type actually, right? So it is if you want T right your T2 micros, the T2 nano you want, right? T5, right? Large. So you need to select that instance type, right? So that you will be reserving for 1 or 3 years. So that will give you up to 72 to 75% of savings. Right? And then you have a savings plan, right? That will be, again, it will be flexible, right? Commitment to a specific hour per, right, a dollar per hour spent, right, across instance families. So here in savings plan, actually you don't have to stick to any specific instance type. It is flexible because you are just committing that, okay, you will be, right, spending this that particular, right, say amount per hour. So you can select, you can combine, right, any instance type when, right, you go for savings plan, right? So best, right, for steady state, right, workloads like core databases or internal applications, definitely. So these are for, right, predictable workloads, right? So steady state, right, that you know that, okay, you have a constant, right, consistent requirement for these resources, so they will be there, right, for long, right? And definitely when you can save up to 70-75%. So, and you know that, okay, you need them, right? So you cannot afford to, right, lose them or terminate these resources. So definitely you can go for, right, these commitment based services, right, or reserved instances, right? Okay, let's get into the KC. Okay, so what is the primary function of a hypervisor in the AWS infrastructure?
Um, it's for hosting. It's like a VM for hosting application and some software.
Okay, so you need to select the correct answer from these options.
Oh,
So
sorry.
which one? No, no
Yeah,
problem.
let
Ah,
me let me look into that. Yeah.
mhm.
Uh, One, to manage VCP peering. That's not correct. To allow multiple VM virtual machine to share the same physical hardware. To provide manage database engine for EC2. So B, to allow multiple virtual machine. Yes. Hypervisor. That
Oh,
purpose. Yes. Yeah.
okay, great, great. That's correct. Okay, second one. Which hypervisor is used for modern EC2 instance types?
EC2 instance type. Okay. Um, I know we talk about Zen and Nitro,
Mm-hmm.
but definitely it's not Hyper-V and it's not LVM. So you talked earlier about when we were talking about the BM meter. Yeah. I think it's Zen. Yeah. I can't remember. Is it Nitro or Zen? Yeah. You say AWS use both for Z. Yeah.
Yeah, it is Nitro or Zen, but it is not Zen actually. For modern EC2 instance types, right? For modern, it is Nitro actually.
Okay.
Right?
Nitro. Okay. Sure.
Yes, yes, Nitro.
So that Zen is what?
Yeah, Zen is, right, for other instance types that we have, right? So the previous generations instance types that we have.
Yeah.
So
Yeah.
for that we have Zen.
Yeah. I remember you mentioned that. Okay. Okay. So Nitro.
Yes.
Okay. Sure.
Okay. Number three, if you have a workload, right, that can be interrupted at any time, and you want, right, the lowest possible price, which model should you choose?
Lowest possible price. Yeah, spot instance. So that's like a instances. That's like 90% saving. Yeah,
Yes. Great.
yes.
Great. Very good. That is correct. Okay. Number four, which pricing model requires a commitment of 1 or 3 years in exchange of a significant discount?
Reserve instances.
Reserved instances. Very good.
Yes.
Great. Great. All right.